Okay, so here we're going to continue talking hydrocarbons, and here we're going to talk about alkyne structures. So I'll talk about naming and how to draw out these structures. Okay, so following IUPAC naming, when we're naming alkynes, it will be the parent chain followed by the suffix -ine, Y-N-E. Note that the longest continuous carbon chain has to contain that triple bond. That triple bond is going to have the lowest locant value, and make sure any substituents go in alphabetical order. All right, so let's start with our first example. Since that we have a straight chain, we've got 5 carbons, we only have the triple bond. That's the only unique feature of this particular compound. When I am naming, it is really important for me to make sure that that bond has the lowest locant value. So that means that I'm going to use this bottom naming scheme. So what this means is since I have 5 carbons, it is a pent. It has a triple bond, so it has a Y-N-E. So this is going to be, let's do a better color than that. This is going to be pentyne, or something, yeah, pentyne. And now I have to let everyone know where the triple bond is. And again, it gets the lowest value. So putting a 2- out front tells everyone that that triple bond is located on carbon number 2. Okay, let's do this next one. So with this next one, I'm going to go through and I'm going to count. Again, I want that I've got 2 things going on. Well, let's count first and then we'll see what we got going on. All right, so I could start here. 1, 2, 3, 4, 5. I could start here. 1, 2, 3, 4, 5. Or I could start on the other side. 1, 2, 3, 4, 5. And I hope you saw when I was naming from the other direction in purple that you know, I could either count this as my substituent or I could count the other carbon as my substituent. Doesn't really matter. Okay, but I can see that I have to use the blue numbering scheme because that triple bond has to have the lowest value. Again, my longest carbon chain contains 5 carbons, so this is also going to be a pentyne. So let me go ahead and let's write that out. Oops. So pentyne. Now, I have, again, want to make sure that I let everyone know where that triple bond is, and it is on carbon number 2. And now I do have a methyl group. Now that methyl group following our blue numbering scheme is on carbon number 4. So I need to add this in. That I have that methyl group on carbon number 4. So this is, I hope you all can read that, 4-methyl 2-pentyne. All right, next we are going to be taking these compounds from their names and drawing them. All right, so now we're going to start with the names and we are going to go ahead and draw these. So our first one is 1-butyne. Okay, so the -ine tells me that I have a triple bond in here somewhere, and the but tells me that I have 4 carbons, and this 1 tells me that that triple bond is on carbon number 1. So let's go ahead and write these out. So I have 1, 2, 3, 4 carbons. Now again, that 1-butyne tells me that I have a triple bond on carbon number 1. So 1, 2. So there's my triple bond. And my last thing I need to do is to add in my hydrogens. Carbon number 1 needs 1 hydrogen to make that complete. Carbon number 2 already has 4 bonds, so that carbon is completely fine as is. Carbon number 3 needs 2 hydrogens to be complete, and carbon number 4 needs 3. And so that is the structure of 1-butene. All right. Now let's move on to 6-methyl-3-octene. Okay, so looking at this, oct tells me I have 8 carbons. So let's go ahead and draw those out. 1, 2, 3, 4, 5, 6, 7, 8. All right, now 3-octene tells me that I have a triple bond on carbon number 3. So 1, 2, 3. My triple bond is right here at carbon number 3. Now the 6-methyl tells me that I have a methyl group on carbon number 6. And for ease, let's go ahead and just number these. 2, 3, 4, 5, 6, 7, 8. All right, so my methyl group is on carbon number 6. This is it. So now what I have to do is go back and fill in the rest with my hydrogens. I've got my methyl group on there. I've got my triple bond at carbon number 3. So my first carbon is going to require 3 hydrogens. My second carbon is going to require 2 hydrogens. My third carbon is fine. My third carbon is done. It already has 4 bonds. Same with carbon number 4. Carbon number 4 also already has 4 bonds. So I'm on to carbon number 5. It is an interior carbon. It needs 2 hydrogens, as does carbon 6 and carbon 7. And then carbon 8, being a terminal atom, needs 3 hydrogens. And there you have the structure for 6-methyl-3-octene.